Good day, I'm Laris Perez and I will show you how to interface servo motors to Gizduino. The materials to be used in this tutorial are the following.
The first one is Gizduino. Gizduino is an Arduino-compatible microcontroller board proudly made in the Philippines. It is designed and exclusively manufactured by eGizmo Mechatronics Central. To put it more simple, it is an eGizmo version of Arduino. That means all the functions, capabilities, pinouts, and board size of the original Arduino is exactly the same with Gizduino.
The next thing is a breadboard. A breadboard is a construction base for prototyping of electronics. Because the solderless breadboard for electronics does not require soldering, it is reusable. This makes it easy to use for creating temporary prototypes and experimenting with circuit design. The next thing is a potentiometer. A potentiometer is a 3-terminal resistor with a sliding contact that forms an adjustable voltage divider. If only 2 terminals are used, one end and the wiper, it acts as a variable resistor or a rheostat.
The next thing is the servo motor. A servo motor is a rotary actuator that allows for precise control of angular position, velocity, and acceleration. It consists of a suitable motor coupled to a sensor for position feedback. Servo motors are used in applications such as robotics, CNC, machinery, or automated manufacturing. So servo motors have 3 wires: power, ground, and signal. The power wire is typically red and should be connected to the 5-volt pin of the Gizduino board. The ground wire is typically black or brown and should be connected to a ground pin of the Gizduino board. And the signal pin is typically yellow, orange, or white and should be connected to a digital pin on the Gizduino board. Note that servo draw considerable power, so if you need to drive more than 1 or 2, you'll probably need to power them from a separate supply.
To start, you need to connect the servo motor to the Gizduino board. Since the pin of the servo motor is female pin, you need to have connecting wires to connect it to the Gizduino board. As I've said earlier, the red wire here should be connected to the 5-volt pin of the Gizduino board. Next, the brown pin should be connected to the ground pin of the display. Lastly, the orange wire should be connected to the digital 9 pin of the display board.
The next thing you will install the Gizduino board to the laptop via the USB. The Gizduino board is powered up, but the servo motor is not functioning. It is because there is no program or sketch for the Gizduino board.
After connecting the Gizduino board to the laptop, I will create a code to be burned to the Gizduino board so that the servo motor will rotate from 0 to 180 degrees and vice versa. If you already installed the Arduino software, you can double-click the Arduino shortcut found on your desktop. If it is not there, click Start, All Programs, then Arduino. As you can see, on the bottom right part of your screen of your Arduino software, it shows where the Gizduino board is connected to a certain port. To confirm that the port between the Gizduino board and the laptop is correct, click Start, right-click Computer, Properties, Device Manager, then Ports. As you could see, the prolific USB to serial communication port is a driver used to create a serial communication between the Gizduino board and the laptop. It also sets which communication port is used. So if this port and the status bar found on your Arduino software is not the same, you can change it by clicking Tools, serial port, and select the active ports which you can connect the Gizduino board there. Another thing you should do is to check the type of board you're using. Since I'm using Gizduino board 80 Mega 328, I'll click Tools, Board, wait, and select Gizduino Mini with 80 Mega 328. By the way, the programming language used for this Arduino software is C. So if you're already familiar with C language, then it will be easy for you to understand how to code this one. So to start, type include servo.h. This library allows an Arduino board to control RC or hubby servo motors. Servos have integrated gears and a shaft that can be precisely controlled. Standard servos allow the shaft to be positioned at various angles, usually between 0 and 180 degrees. Continuous rotation servos allow the rotation of the shaft to be set to various speeds. The next thing I'll do is to create a servo object to control the servo. To do this, type servo, my servo. I will declare also the position of the servo motor, which is zero. I'll add a function called weld setup. This void setup is called when a sketch starts. It is used to initialize variables in modes, start using libraries, etc. The setup function will only run once after each power up or reset of the. So inside this void setup function, I will declare the servo attach 9. So it attaches the servo on pin 9 to the servo object. The next thing is to add another function called loop, void loop. As the name implies, it loops consecutively, allowing your program to change and respond. It is used to actively control the Arduino board. So inside this one, you can control your shaft starting here. To do this, I'll declare a for loop statement. For position equal to 0, position is greater than 180 degrees, position plus equals 1, plus equals 1, my servo, that's right, then delay 15. So for the first part, it will rotate the shaft from 0 to 180 degrees. If you want to turn it back to its original position, declare another for statement. For position is equal to 180 degrees, position is greater than equal to 1, pos minus equals 1. My servo, that's right, pos then delay 50. So to check if your code is correct, click verify. At the bottom of your Arduino software, you should see the status wherein your code is correct or done compiling. If it is not, it will show an error like this. Variable or field setup declared void, which means there is something wrong with my void setup function. Since I forgot to add close parentheses on the void setup, so I'll put it there. Then I'll click verify again. You see, there is a compiling sketch. Then if there were no errors, it will done compiling. If it is done compiling, you can upload it to your Gizduino board by clicking upload. So it's compiling the sketch again. And it's done uploading. The servo motor will start to rotate from 0 to 180 degrees and vice versa.
The next thing we do is to control the rotation of the servo motor to the Gizduino by using the potentiometer. Before I connect this to this breadboard, the potentiometer has 3 pins. Pin 1 should be connected to the 5-volt pin of the Gizduino board. Pin 2 should be connected to the E0 pin of the Gizduino board. And lastly, pin 3 should be connected to the ground pin of the Gizduino board. To start, you need to put this potentiometer to the breadboard. Then, this connecting wire should be connected to the 5-volt pin of the Gizduino board. Then, the second pin of this potentiometer should be connected to the E0 pin of the Gizduino board. Next, the third pin should be connected to the ground pin of the Gizduino board. So these wires from the servo motor should be connected to the 5-volt pin and the ground pin.
The next thing you do is to connect the Gizduino to the laptop again via the USB. You see, the same thing happens as the first one because different program or sketch has been prepared here.
So if you want to control the shaft of the servo motor using the potentiometer, so I'll create another page for it. So I'll click File, then New. For this sketch, I will use the same code as the first one, but there are some parameters or some parts of this code will be changed. So I'll copy this one. It will be I'll use the same servo library, servo.h, then the control subject, control object, I mean. Then I'll add another parameters here. Still the same, in position equal to 0, in potent equal to 0. This will initialize the analog pin to be used to connect to the potentiometer. And another variable called val to read the value from the analog pin. In the void setup function, you cannot change or you will not add something to this part. So let's proceed to the void loop. Instead of using for statement, I'll just erase this one. Outside val equals to analog read potent. So it will read the value of the potentiometer between 0 and 1023. Then value equal to map 0 5 0 1023 0 179. So this map remaps a number from one range to another. It does not constrain values to within the range because out-of-range values are sometimes intended and useful. So the next thing I'll do is to write my servo that val my servo write that val or I mean parenthesis val. So it will set the servo position according to the scaled value and I'll add delay. So to check if your code is correct, click verify. And oops, there is something wrong within your void loop. So since there is no comma here, so I'll add here, then check it again, verify. Oh, another type of error. Let's verify again. So it compiles the sketch. It's done compiling. So you're ready to burn it to your Gizduino board. Click upload. So there you go. You can control your servo shaft, or I mean, you can control the rotation of your servo shaft to your Gizduino by using the potentiometer.
So that's it. I hope that this tutorial helped you improve your Arduino skills. Thank you for watching and God bless you.